Welcome to this talk, Scale Your Efforts with Scala. My name is Daniel Sumanovskis. I work for ArcCore. And here is briefly what I will talk about. So I'll first explain who we are, what our company is, why we are using the Scala language for our Eclipse development, how we use it, what practical problems we have had with that, and how we go about learning the language for development everyday work. So who we are, ArcCore, it's a company based in Sweden. It's a small company in the automotive industry. And what we work with is a thing called AUTOSAR. It's a worldwide automotive industry standard for automotive suppliers and manufacturers. Then there is the Eclipse Automotive Working Group, which we are not part of, but which is closely related to this. And most of the company works with embedded products, so embedded automotive solutions, but we also have a product called Arctic Studio, which is an Eclipse-based configuration environment for automotive software. So this Arctic Studio, this is also the product that I am working on. So it's an Eclipse RCP application, and it makes use of EMF because AUTOSAR is represented as EMF models. It makes use of RTOP, which is not an Eclipse community project. It's a separate project, but it's basically the implementation of AUTOSAR in EMF specifically. Then we're using Sphinx, and we are using Xtext for a whole bunch of things. We are using that for code generation, which is a really big part of the AUTOSAR workflow, and we're using Xtext also for some domain-specific languages. So, yeah, as you can see, it's just a normal Eclipse-based product, looks like Eclipse. And for a lot of work on Arctic Studio, we are using Scala, Scala is a JVM language primarily developed by Martin Odersky. And why do we use it? So Scala is a language that it's a functional language, so we can use functional programming for development, but we can still mix it with object-oriented programming because Scala is not purely functional, it's also completely object-oriented, so we can use all the usual object-oriented patterns. We find that we are writing much less code in general for the Scala parts. We find that the collections API is perhaps the best thing about Scala. So especially given EMF work, there is a lot of work on lists, there is a lot of filtering, there is a lot of searching, and Scala is largely built around easy work with collections, so it has a top-notch API for that. We use Scala because we don't want to check for null, so Scala has a built-in optional type that I will have some details on later, but we don't ever write null in Scala code unless it has to send a null explicitly to some Java code that expects it. Other than that, it's not needed. Then next, I'm really happy that Ed Merckx yesterday was talking about how Java 7 is everywhere and how it's obvious and so on, but unfortunately, that's not the reality we have. We still have to deploy for Java 6. And maybe we will be able to roll out Java 7 later this year, maybe not. So we don't have the option of programming in Java 7 now, definitely not Java 8. But with Scala, we do basically get all of the new functions in Java 8. But Scala compiles to Java 6 bytecode, so it runs on JDK 1.6 completely. So Scala, as I said, it's a functional language. So what it can do as a functional language, it's the things that you would expect. So you can write without any mutable variables. Every value that you declare is a constant. And then you write functions that do not have side effects, that just they don't modify their parameters. They accept parameters, calculate some value, return something, no mutability. Then collections in that collections API, which I mentioned, and logical predicates for collections or elsewhere. They are handled in a very functional way. So for Java, I guess many are using Guava collections, and the Scala collections API is similar to that in terms of functionality, but not in terms of syntax. And then there is LinkU in .NET, which is syntactically a bit more similar to how you use collections in Scala, so it's a very functional approach. And as any functional language, Scala has functions as first-class citizens, which means you send functions around as parameters, you return functions as return values from other functions, and so on. So Scala can be used in this functional manner, but you don't have to do any of that. So if you want variables, you have variables. So all of this is strictly optional. Likewise, Scala, it's an imperative language, it's an object-oriented language. You can write it like Java without semicolons, which is what people who begin programming in Scala usually do. They write very much in Java style, just with a slightly different syntax. So Scala, it has all the object-oriented features that you would expect. So it is like Java. Yeah, you have abstract stuff, you have overriding stuff, you have inheritance, all of that. You even have some additional object-oriented features that are not present in Java, such as composition by mixin, which is maybe a bit similar to extension methods in C#, or a bit similar to default interfaces in Java 8, but basically you are adding some functionality to your classes by including traits which correspond to Java interfaces. So it has a bit more object orientation. Just, for example, everything is an object. You also hear that about Java, but in Java, everything is not an object. So the literal number 2 is not an object, it's a primitive value. In Scala, even that is an object. So if you have the number 2, you can call a method on it, and you can write weird stuff like 2 period plus to call the plus method if you want to write it that way. So you mix functionality and object orientation in any way that you want. So then what you get is Scala can be called a post-functional language, which is not something I made up. It's that the language's creator gets asked very often, is Scala a functional language or is it not? And then he wrote in one blog that, okay, let's call it a post-functional language in the end. So, and that is how we use it pretty much. So we use the functional aspects when we need, we use the object-oriented aspects when we need. Specifically, so this collection API that I say is great. What we have, for example, in Java is a typical situation. We have a list of something, then we need to go through that list, we need to apply some filter on that list, and we need a new list of some stuff that matches some condition. So it's a very typical situation. And then what you do is you start with an empty list, then you do a for loop, then you have your condition in the for loop, and then you just add elements to your list. Usually this is what you do if you don't have Guava or something else. And especially now, after writing Scala, I feel that it's not only that you have more code in Java, it's also, it doesn't really express what you want to do, because, okay, so you are making an empty list at first, but you don't really want an empty list at any point. You are adding elements one by one, but that's also not expressing what you want. You don't want them one by one. In Scala, instead, you just use the collections API. So you take your list, you apply 2 functions from the API, which is first map, that you do something for every element on your first list, and then collect, which means that you build up a new list for everything that matches some condition. So write map, collect, your predicate, and then you have it. So in less code and in code that is far more closer to what you actually want to get. Or another example would be when, okay, let's say we have the situation, we have a hash map. So the keys are frames in some communication bus. The values are send or receive, that is the direction of frames. But what I want is logically really simple. I want to separate the send frames, I want to separate the receive frames. So again, in Java, usually you would create 2 sets maybe, then go through the entire hash map and add elements one by one, which is, again, a bit too much. And then you find the next problem. Okay, in Java, you cannot really take the difference of 2 sets. So then what you do is you create a copy of the first set and remove all elements that from the copy that are in the first set. It's a bit weird. In Scala, again, it's more direct. You say, okay, take your hash map, collect everything that is send. And that's one set. and the other set is just the diff, everything that is not in the first set. So this is how you work with collections in Scala, and after just a bit of experience, it does become much easier. Or for a more complex example of Scala code, you have something like this, which is complicated. Even if you know a bit of Scala, this is complicated. This is some code that handles the internal collection logic of various software components in a system. So yeah, it's a bit complicated, but it's this amount of code, and so if you have this in Scala, then the corresponding in Java is that you don't really have anything. So the corresponding Java code, it requires several helper functions, and it's more code than I could show in the presentation. So it doesn't really work that way. And yeah, I promise that code, it's not Perl, so it's not write-only code, actually. Next, option type. So a safe alternative to null, which is why you don't write null in Scala. Semantically, of course, it's very similar to the optional type from Google's Java extensions, but it's a core part of the language. And what you get is that you are writing when you write code, so you have at compile time whether your function will return anything or whether it may fail to return a value of that type. So if you have a function that finds an integer in a list of integers, which is a silly example, but it works, then this function may logically fail to find the integer, in which case it returns an integer only optionally. So then the return type is an option of integer. And then the result of calling that function is also an option of integer, not an integer. So essentially, when you use this, what you get is that for every value, every function, you are saying explicitly at compile time whether it is nullable or not nullable. So if you have a function that returns something, you must return it. If you may not return it, then you have to make it an optional. So no more null pointer exceptions. Instead, it's only compile errors if you've done something wrong, which is much better. So in addition to simple cases, it's nice in simple cases, but then we get stuff like EMF code. We have to chain a lot of function calls. So we have an EMF model, then we need to get that, nested several levels, and at least with the AutoSAR meta model, it happens that almost everything can return null. There are a few nice features that will never be null. They will return empty lists perhaps, but lots of references that may return null. So that Java snippet, it's a pretty typical code snippet for something like what we do. And so it's not a lot of code, as you can see, but it has, so what, 5 null checks it has. Because otherwise it crashes at some point, maybe. In Scala, instead of course, this is not a direct correspondence to that code, but it's a chained function call. In Scala, if you have code that might be null somewhere at any point in your chain, you surround the whole call with a try, parentheses, and then you're done. So if null happens at some point in there, then your return value will be a special value indicating that, okay, it did not succeed, that you can check for or pattern match on. So this is, again, one of our code saving things that we do. The next thing that we use a lot are case classes. So those who know functional programming know the concept of pattern matching, which you have constantly in functional languages, but case classes, they are fairly specific to Scala. And so this is an example from the Programming in Scala book, where you can see the very simple syntax of case class declarations. And roughly what case classes correspond to are classes that have automatically generated getters, automatically generated setters, and global factory methods to initialize a new value of that class. And these classes can be used for pattern matching, which means you can check if some value which you have in your code, if it is the same as a value of this case class with some arguments, if you have arguments, which makes case classes excellent to represent data structures that you might have in parsing something, any tree-like data structure. So if you have anything tree-like, then your nodes should probably be case classes. So it's no coincidence that the example here from the book is one of parsing arithmetic expressions, because then things like numbers and operators, you would want them to be as case classes. Saves you a lot of code, and I will show later on that we are using this mostly to represent internal structures that we may be importing from other software, because then we need some internal representation, and case classes are the solution in Scala. Next, like I said, we have to write code that runs on Java 6, but then there is a lot of Java 7, Java 8 stuff that we don't get, but we do get in Scala. So just as a few examples, Java 7 introduces the diamond operator so that you may skip very long variable declarations. In Scala, it works pretty much the same way. You just don't declare the type twice. Java 8, of course, introduces lambdas as one of the biggest changes. Scala has lambdas, as any functional language would have. Java 8 introduces default interface methods, and Scala has a direct correspondence to that. It has things that are called traits, which are roughly like Java interfaces, and you can have implementations in those. Or then Java 8 introduces the streams for working with collections, and they work a lot like the Scala Collections API, except they still lack a lot of that functionality. They are very similar. So we get all of this, and it runs on JDK 1.6. There is now an experimental branch of Scala which will require Java 8, but that is a separate branch. It has not even been publicly released yet, and they will be retaining Java 6 compatibility for the time being. So what do we do specifically with Scala? One thing we do is code generation. We do code generation a lot. It is, as I've mentioned, it's a key component of the AutoSAR workflow. You have to generate a lot of C code. So in the automotive industry, you're not allowed to do any dynamic memory allocations or any such unsafe things. So all of your software has to be statically configured, which means a lot of C code. So all of that code has to be somehow generated, which we do in Scala, which means both that we represent the internal logic as Scala, we do the calculations, computations that will result in the code in Scala, and then the actual output, the actual generation, it's also Scala for large parts of the code base. Works very well, probably wouldn't work to maintain in Java, would be very, very challenging. Next, importers. So, of course, as with any software, we have to import data from other software, other formats. There are formats that describe communication buses. There are formats that describe, for example, diagnostic information in a car. All of that we need to be able to import. So what we do is, again, Scala, case classes. We build up a data model representing whatever we are importing, Scala. Then we do transformers, which transform that to the corresponding AutoSAR configuration, still Scala, very well. And unit tests. This is how the use of Scala at ArcCore began. Actually, at first it was Java for the code, Scala for the tests. Then we found that we like Scala. And unit tests in Scala, they work pretty much in the same way as Java. Just you are writing in Scala, so with all the functional things that you may want to use them. So specifically these things I mentioned, like imports with case classes. Just a brief screenshot from some internal data model from one of our importers, just to show that most of the code, it's case class declaration. So we have a few case classes, and they declare a large part of the data model with very, very little code. So we don't write a constructor explicitly, we don't write getters, we don't write setters. Works very well. Then when we want to generate code, we have nicer string interpolation in Scala, which means that we can write a literal string, and then into it we can insert some variables or some calculated values. Java still does not have anything like that, and it's much nicer than typing string.format in any case. Unit tests. So the advantage about doing unit tests in Scala is that it feels immediately familiar to Java developers. You are using the same workflow as you normally do with JUnit, with Eclipse. So for JUnit, you just use JUnit. It's the same UI, same runner, no problem. For writing your tests, you use one of the several frameworks which exist, like Scala Test or Spex2, and they have various options. You have options that will enforce a particular style of test cases, like behavior-driven style or other styles, or just any freestyle which you want a lot, which you want at all. The Scala test framework, it's fairly similar to how the Cucumber testing framework works. So it's, again, somebody who has tested with Java should be able to do this right away, pretty much. Mocking, again, there's Scala mock, there is Mockito, there is Easy mock. Same concepts as usual, same approach as usual, slightly different syntax, usually code saving. So we use Scala mock, but all of these three frameworks are fairly complete. All of them have a few kinks maybe, but yeah, no problem again. And then if you want to check for your code style, or if you want to enforce a particular style, you use Scala style, which is more or less a direct alternative to check style for Java. It works in pretty much the same way. And what you do not have for Scala yet is something like find bugs. Fortunately, find bugs sometimes thinks that it can run on plugins with Scala code, but then just gets a lot of weird output, so that does not work. Then when we write test cases, so they even end up looking quite a bit like plain English, so that something get children length should equal 0. This is the Scala test framework, so quite readable test cases, I think. So, and I mentioned we do all of this in our product in Arctic Studio, which is an RCP product. And specifically with regards to that, what experience we've had. So there are no problems integrating with Java. We have Scala classes that are derived from Java parent classes. We have it the other way around. We are calling Java functions from Scala. We are calling Scala functions from Java. We are mixing Java and Scala classes in the same plugin. There are no problems with that. There is sometimes a little bit of extra syntax that you need if you're calling Java from Scala, but there is an optional import even that you can add that removes the need for that extra syntax. So that works well, and any Eclipse plugin we have that uses Scala, it needs one extra dependency in the plugin manifest. So we add the Scala standard library, that's it. And the product is, of course, built with Maven and with Tycho, which is the typical. Maybe we would like to build with Gradle also would be interesting, and I know that Gradle also supports mixed Java and Scala builds. But here, if we're building with Tycho, what we get is, again, we are adding one plugin to the POM in the Maven project, the plugin being the Scala compiler, and that's it. It works. It works to build, no problems there either. So far I've said a lot of good things. So it sounds like everything works, which it does not, of course. There are a few things that are problematic. So first of all is this, which everyone on my team sees a lot these days. Scala compile times are very, very long. So it is inevitable because the compiler is smart. It does a lot of things. It can deduce a lot of types. It produces a lot of code that you don't have to write, but it comes at this significant cost of compile times, to the extent where in Eclipse itself, compiling one larger Scala plugin easily takes the same amount of time as like 20 Java plugins. So if you need to do a full rebuild of everything, you do a rebuild and then go for lunch. There are coding guidelines which you can use to keep those compile times from getting completely out of hand. And we do use them, otherwise it would be probably unmanageable. But yeah, compile times are a problem, easily. I should note it's only compile times. There is no problem with runtime performance. The compiled code, it runs no slower than Java, but yeah, the compilation is very, very slow. Likewise, there is a problem with or breakpoints or debugging, or I should say a problem with tool support in general. The tools are not quite ready. I should say the primary tool that you would use for Scala development is the Scala IDE, which is again a Eclipse-based product, or you can install separately as plugins into your Eclipse. And not all Eclipse functionality works. For example, whether searching on particular symbols works, it's a bit hit and miss. And breakpoints. So you set a breakpoint. It will probably break there, but then if you try to do a step, you don't know where it will step. It might step into some unrelated code, or it might step backwards. So it's a bit weird. If you write good Scala code, we find we really need to debug much less than Java code, because if we write that we have no side effects, we have no variables, then we get very reproducible behavior. So with the same input, we do get the same output. So if we have a bug, we do get the same bug all the time. But sometimes, of course, you have logical error, or sometimes you need to debug, and then it's not great. Likewise, I wanted to say here that they do not support hot swapping. That was still the case when I began preparing the talk, but now they do. They added support for hot swapping into debug instances a couple of weeks ago, and that works so far in my experience in most cases. But yeah, the tool support, it's a bit tricky. And then finally, no, not this. Yeah, the memory usage. So it's not just the compile times, the memory usage of Eclipse itself when you are developing Scala, it's also considerable. So on my team, we upgraded to machines with 16 gigabytes of RAM from 8, and it made a big difference for Scala. It's also a very rare case, but Scala is one of the few languages where I've seen errors that the compiler runs out of memory. I've seen some of those on the build server. So you need memory, and you need a lot of patience when you are compiling that, unfortunately. Those are the main problems. And a few words about what we do to learn Scala, because there's been a lot of talk about Scala maybe for the past couple of years, but you don't easily hire developers that have Scala experience. What we will do often is that we will hire Java developers who have Java experience. And we find that Scala is quite friendly to Java programmers because, like I said, it's the fact that you can write it like Java. It's the fact that you can begin writing Scala after a very quick syntax introduction. You can be using familiar tools. So as long as you're writing object-oriented, you can be using familiar patterns. So you do write right away. And then the more experience you get with Scala, the less that code looks like Java. But there is not such a super high barrier to entry, fortunately. Specifically, we've been using this course on Coursera, Functional Programming Principles in Scala. It's a course that is given by Martin Odersky himself, who developed the language. There have been, I think, 3 or 4 times that the course has been given on Coursera. And we found it to be a very good course. It's, of course, not in-depth, not as in-depth as a proper university course maybe, but it's a very good introduction. And we found that people who do the course, they watch the lectures, they do the assignment, they have been able to right away start writing, start contributing something to our Scala code base with decent style. And yeah, Coursera is pretty decent, of course, itself. And by the way, their whole backend is written in Scala themselves, so they are heavy Scala users. So that's a great introduction. For more in-depth, we have, there's this book, Learning in Scala. So it covers pretty much all the aspects of the language, covers advanced features, and unlike many programming books, I think it's quite interesting that what this book often does, it explains why things are in a particular way in Scala. So it explains what the language creators were thinking when they were making a particular design choice. So this is a good source for in-depth information. And then that's almost it. I have some links for when these slides get uploaded somewhere to the software that I've mentioned. So please remember that this session, as all the others, can be evaluated on the conference website. And with that, I conclude. So if you have any questions now,